Hello, candidates to the AQA Computer Science A level. This is a paper 2 video. I stumbled upon this in the last live stream, and I think that's a good one to do. This is one of those, where they give you the table, one of those AQA assembly. But this one asks you to write code, which in fairness means that you don't need to know about the names of the register, what they do, whereas, there's some traces where arguably you might. Debatable. So here's the problem we're trying to solve. Always helpful to know that. We want to display the value of the contents of a memory location where we will get a byte, 8 bits, and we want to display this in hex. So that's 9e, so we want to actually display, this is the character for 9 and this is the character for e. We want this to, of course, work with any 8-bit number, because 8 bits, that's 2 hex characters. So we'll be reading this from location 100 and storing the ASCII code, this one in 101 and this one in 102. This is important, we'll need this, masking and shifting. Those are not the ones you tend to use very much in the traces. It's not like your add-in branch sub as well, arguably. MVN. Oh, that's a bitwise not. Yeah, there's some kind of bitwise. So we'll be using both in our instance. We have also a table to convert from ASCII to that. So if you see this, the first thing is, of course, take a couple of deep breaths and don't panic. This is much easier than it looks. Let me fire up the text editor, which I should have that ready. I'm not going to do it. I'm going to run it in this at the end, which is Peter Hickson's Little Man Computer specifically for the AQA language, assembly language, improved actually, because this one does support indirect addressing. So in the spec, you're asked to know about direct and immediate addressing. But if you know the existence of an indirect addressing, actually it makes much more sense which one is direct and which one is immediate. Immediate. I don't know what the accent is on this word. Let's have a new document and make that pure text. No, plain text. And we can even, whoa, I'm going to save that. We can zoom with the same shortcuts as in a browser. Yeah, okay, cool. So, the first thing we want to do is actually write what we're going to be doing in kind of in English. The main thing here is that there's two tricks. The first one is how do you get, well, I've got it all wrong now. How do you get this or just that? And this is what they mean by masking and shifting. So let's start by loading. They tell us the value is in. So we're going to load the value in, say, R0, whatever, right? R0, right? Okay. And then we're going to copy it to R1, copy it to R2. Okay. Let's say that R1, wait, what do they want where? This is important, right? First left hand, so 101 should be those four. Well, no, it should be those four, and right hand is here. Where was my text editor? Can I, okay, how about this? And here. In R0, copy to R1, copy to R2. So let's start with R2 because it's going to be simpler. R2, we want those. To get those, this is why you have the bitwise end. Masking is a bitwise end. So what I want is to do a bitwise end of R2 and 0, 0, 0, 0, 1, 1, 1, 1. So because we're doing bit by bit and end, this is only going to keep whatever was on those 4 bits. This is what they mean by masking. Masking is a bitwise end. This is 15, right? So that's, we can make a note of this. I use hash because, yeah, I'm not in my right keyboard mode, because remember, if you prefix the number by this, that means the actual decimal value 25. They will accept hash 001111. I don't know, no, probably not, because this is the only one you've got to go. I'm gonna have to do some binary to decimal conversion to actually put, you know, the test values and check the test value in here, but we'll cross that bridge in a second. So that will, this is the left, the right hex digit. Maybe I need a bit smaller. My hex digit, and okay, for that one, for the first one, for R1, I want kind of like those four, but I want them here. Because I want the number, right? The number, the actual hex number for this is 1001. So this is where I'm going to use shifting. I could use masking and just like keep those four, but I would, in order to move them, I would need to shift them anywhere. And since like anything I shift, you know, out is going to drop off and be ignored, and we're just going to have zeros to the left. We're fine anyway. So I'm here. I'm going to do 4 logical right shift of R1, and now this is the left hex digit. Okay, but that's the value, right? That's the value of the digit. So I need to now actually get the character. Sorry, this is the right, yeah, this is the right hex digit, essentially. This is the right number, but it's not a hex digit value, right? But like not the hex digit character. This is the problem. So let's say, right, so this is what, like 11001, that's meant to be 9, fair enough. No, this is 9, right? Let's start with this, because this is a lower than, you can tell we're gonna have a problem when we start an A, right? So this is 9. So this, yeah, because it's 8 and then 1, right? It's 9. So we want this to map to 57, and we want, because we want 0 to map to 48, what I'm going to do is I'm going to add 48 to both. So add, well, let's start with R1. You know what, I'm going to do them like, you know, kind of character by character. So we're doing R1, which is the left one. And it's, we've got it in the right place, right? So the least significant bit, I add 48. So I add, I'm going to just say, I'm going to write it like this, which is going to start looking a lot like assembly, because that's the order, by the way, the commands are in the same order as you would like this. So it's like destination and then the two sources. And then if the result, now if the result is equal to, that's the trickier bit. What I want is like, if the, remember, because you can't really, you can't do all comparisons. And also it's simpler when you do what I want. The principle of what I want, right? If R1, so in English, if R1 is like larger than, like larger or equal to 58, right? So if we pass this, we want this to be, we want this, if it's, let's say let's say it was 10, right? So let's say it was 58, then we want this to become 65. So we need to add 7. So that means R1, sorry, let's put it in order, equal to R1 plus a decimal 7. That's the crux. Like we would do this like also here, except, do I do? Oh, this doesn't do like command D, except with R2, right? So okay, well, no, let me finish it up there, and then I can copy it, whatever, right? Now, in assembly, because you're testing and you're branching to somewhere, it is much easier to test the opposite. So I want to say if it's larger than 58, and I'm gonna branch to skip, which means I'm only gonna run this line if it's, no, if it's smaller than 58, if it's smaller than 58, right? I'm only going to run this line for the larger than 58 or above. So like, you know, A, B, C, D, or the things that I want to become A, B, C, D, but like 10, 11, you know, or like 1, 1, whatever, right? Kind of those numbers. So I'm skipping this, and then I've got a label skip. and then that's, you just kind of move on. So if you just, in assembly, if you just get an if-else, it's much simpler. So an if-then, if you really want to do an if-then, you're going to test for it, you need to kind of send the program counter somewhere, and then at the back have a branch back to your branching point, and have your regular code continuing through. In fairness, I suppose in the real world it depends how likely one is the other, but like one will give you, even in one algorithm only kind of requires one skip, the other will require two. So both performance-wise and code-wise, it's simpler to do kind of test the opposite and just skip to if it's not. If you get an if-else, you're going to need to have two branches, two branch instructions. Right, so this is this. And in skip, we're just going to copy. When I say copy it now, I'm referring to R0, and same deal. And so now we're doing, we're doing the same thing for that, right? So let me write it in assembly then, right? So this is, so it's like LDR. Oh, okay, so the commas are, right, so in R0, I want 100. Then to copy, it's move. No, that's actually kind of like, yeah, no, that's kind of move will operand 2 can be an address or a register, right? The operands can be an address or a register. So I'm going to move it. I like to move it. Move from, so that's the source, then the move is like this. No, into register D. Again, so this is like, this becomes equal to that, right? So I'm going to say R1, R0. Let's, I guess, like be consistent in the styling. Then could also, it's like left, shift, logical shift, right. And store in the result. So we're not changing the thing. So we say R1 becomes equal to R1 logically shifted to the right by 4. Operand 2 can be a, oh, this is not, memory ref is only there, right? So operand 2, well, that can be literal, that can be a kind of like immediate addressing. So that's a hashtag 4. Still need the hashtag though. Hash. Fine, so that's done. This, so this is like it's add R1, comma, R1, 48. Now that we're going to testing, the test is kind of done, you just do compare. So we're going to compare R1, a literal 58, and then to branch to skip, we're going to say branch. So if they're smaller than 58, so that would be BLT, like the sandwich. Branch slower than skip 1, because we're going to have 2 skips, right? Here, that's an add R1, hashtag 7 spaces, skip 1, and then we're back here, right? So like I can probably do literally just that one, except the well, no, I can't. I'll do it by hand. Okay, so let's move R2, R0. We still have the original value in R0. There's no issue here. Then we not left shift right. This is where we're going to do an end. We put the result in R2 of R2 and literal 15. Yeah, no, yeah, 15. Like the, yeah, I'm trying to confirm. So this 1111. That gives us the right hex digit. So once we've had this, we need to basically do this. Ooh. Up, except I'm actually gonna find all of the instances of 1 and 1, and then replace them from this point onward by 2. So my skip is also skip 2. R1, so this is them, it's R2, skip 2, R2, 7, still 7, right? Because like it's just to kind of move it in the ASCII table towards the 10 becomes an A. Skip and skip 2. That's it, right? There's nothing. What the moment you want to know, Smanis? Yeah, that's it. I think we're done. So skip 2, and then we halt. You know, this is always good practice to finish by a halt in an assembly program. Otherwise, the program counter just will read whatever's next in memory, and then you get trouble. This is how viruses and kind of malware work, essentially. Well, the OG malware before you did like JavaScript cross-site scripting or dumb stuff, dumb modern stuff like that. Okay, get bigger. Right, so I'm going to take this, I'm going to copy it. I've not tested it before. This is going to be as exciting to me as it probably is to you. Hopefully. What have I done here? Oh, sorry, you don't put the colon when you're going to a label. You only put the colon when you kind of labeling. That's the problem now. Oh, that's, yeah, I can't spell. I kind of like, so far, so good. I still can't, no, I could spell, this time I could type. I couldn't type. That's because it's not a label, it's, oh, it's, oh no, that's not what I want. What I want is this one. And our operator 2. And operator 2 is, yeah, you're gonna have the problem here. That's probably missing a colon, something dumb. Yeah, it's missing a colon. Okay, so which means that is this one gonna miss? No, this is the masking. This is end as in masking. Add is adding. Cool. Right. Okay. So let's put. What do we want here? Yeah. So this is where I'm going to need a bit of conversion because we start with this, which is 127 plus 16. 128, right? 128 plus 2, that's helpful, 130, right? Plus 4, 134, 142, 167, no, and 57, yes, 157. I hope I get that right, otherwise it's going to be embarrassing, right? If I can't convert to just... No, come on, I trust myself. That, yeah, 28, 2, 4, 8, 12, and 16. That can't be right. No, maybe I don't trust myself. Fine. Okay. 100. Yeah, this one, right? Like it's this guy. 158. What did I say? 157. Yeah, close enough for government work. Right. That's loaded. We'll assemble. No, assemble wipes the memory. So we just type run basically. Sorry, that's assembled. Assembly has put it over there. That means putting it there, and the program counter is now pointing. Where's the PC? At 0, right? Like so we start again. This is where this is in, right? And then we run it. So it gets it's read the address. We know where to fetch it. It goes and look for it and puts it in R0, and then it then looks at the second instruction and then that's copied it to R1. And that's 9. Yeah, which is that's the number we wanted, right? So we're happy that it's 9. This is converted into ASCII 57, which is where we want it, and then we're starting to do the same thing about R2, I'm gonna guess. Oh yeah, this was the skip. Now we're like, let's not go it. That's 14, so this is gonna be E, because it's larger than 10. 62. Which is larger than 58, so then we are going to add, I'm going to add to it, right? I'm going to add to it. Adding to it, yes, 69, hey. And ASCII 69 is the right one, right? E, yes. So we have, yes, 69 and 57, which were, I mean, I'm not going to verify that it's like, that looks like those two numbers, right? Like that's kind of definitely 59, 9, and no, sorry, 57, 9, and 69E. Yeah, okay, so that's See, it's not that. It's just don't panic. Trust your instincts. Remember, like line out what you want to do, so you know where you're going, and then you can convert pretty much each line into assembly. If you start writing straight in assembly, it's a little bit dangerous, and unless you're feeling pretty confident, because it's hard to look at what you've written and figure out what it does. And the other tip is, like, remember, if you want to do a simple if-then in assembly, it's better to test the opposite and then do a skip over the part that shouldn't happen. Right, thanks for watching. Paper 2 is not next week, but paper 1 is less than a week to go, so good luck.